All right, we are going to go ahead and get started today. Good morning. Thank you for taking the time to join us for today's webinar. My name is Jennifer Midland, and I'm a marketing manager at Munters in the Food Tech division. I will be moderating today's webinar. We wanted to cover a few housekeeping items before we get started. All of attendee microphones have been muted for the duration of the call, but that doesn't mean you can't get in touch with us. There's a chat function and a question field that you can use to communicate with us throughout the webinar. We will be taking cooling pad questions around halfway through, and then we will be moving on to the fan maintenance section, and you can submit questions after that part of the presentation is complete. We have provided several handouts for today's session as well, which are available in the handouts section of GoToWebinar, including a PDF of today's PowerPoint. Lastly, the video will be recorded and shared with you via email afterwards. Right now, I'd like to introduce today's speakers, David Baker and Ross Demerly. Okay, David Baker is our CAD manager and application specialist. He has been with Munters, formerly Aerotech, since 1993. David will be giving the majority of today's presentation. Also on the line is engineering sales manager Ross Demerly. Ross has been with Munters for 30 years and assists with sales, product applications, and building design. We are ready to get started. So David, the floor is yours.
Thank you. Today we're going to talk about cooling pad and fan maintenance. Thank you for joining us. And we'll go ahead and get started with evaporative cooling. So why is maintenance important, both for the evaporative cooling and for the fans? One, for air quality, we want to maintain a proper air quality by removing moisture and ammonia and dust without causing excessive bird chilling or animal chilling. We also use it for temperature control. We use heating and ventilation systems to maintain an optimum temperature for the animals. And then also we want to provide proper air quality and temperature with minimum energy usage by keeping our equipment at a peak efficiency. So for maintaining the pad, we want to clean the distribution pipe holes monthly, and the collection that out yearly. The inline strainer, we want to clean that out weekly in hot weather, during the hot weather when it's in use a lot. The sump tank and float valve and foot valve, if you have a non-submersible pump, we want to clean those out monthly. Okay, the other thing we want to do is when we're cleaning these other parts, we want to check the pad material, make sure there's no damage to it. We want to check the cooling control at least monthly, make sure it's running and working properly. We want to check the system for leaks monthly, and then we want to bleed off the water to prevent mineral buildup and to prevent early pad failure, reduce the number of on-off cycles. We want to remove any debris and flush the water distribution profile with clean water. We want to make sure that the holes are facing up so the water splashes down across the top of the pad. And should be something like this. Yeah, we want the water to splash off the pad and go down onto the pad. So we want to check the pressure in the distribution pipe. If the pressure is too weak, the water won't break up when it hits the splash cover, causing streaking and dry spots to occur on our pad. And so what's the proper pressure? How do we test that? For our 6-inch evaporative pads, we want a water jet of 11 inches using the 3-inch hole spacing, which is what we use at Munters. And for much longer systems, 70 to 80 feet long, it's it's typically less expensive to use 2 pumps rather than 1 large pump, both for initial cost, but also it provides other benefits like animal safety. Losing 1 out of 4 pumps would be much better than losing 1 of 2 pumps in hot weather. It's also easier to transition into evaporative cooling mode, since you can run 2 pumps instead of 4, providing partial cooling. So for the longer systems, we either want to use a center pump like this one here on the left, or we use 2 end pumps like this one here. So the water requirements for systems over 60 feet long, generally we want to put a center feed system in and supply the water from the center. So how do I know I have enough water flowing over my pad? An easy way to check it is when the water is flowing over your pad, place your hand on the pad like this with your thumb pointing down, and you should get a small dribble off of your thumb, and that's one way to indicate that you have enough water flow on your pad. We want to clean the trough out, and we also want to make sure that the drain holes are clear and not obstructed so that the water can make it down into the pipe. We want to clean our filters regularly. A dirty filter will reduce the water flow by over 50%. And that filter there, I'm not sure how any water was getting through there, but that's what we want to make sure we get cleaned out. We also want to clean out our float valve, make sure it's free of any obstructions, so it has full range of motion to allow the water to flow in, and also to stop the water flow when the water's to wet out quickly and stay wet. And you can tell that you have a problem here in this one here. All the pads are not wetting out, so you know that you have some plugged holes in the pipe. So the correct orientation for our pads, there is directional indicators on the side of each pad, and what that shows with the 15 degree, that allows the air to enter the pad smoothly, and the 45 degree angle will direct the water towards the incoming air side of the pad, so that the air has a maximum amount of time to evaporate the water. And if the pads are in upside down, so that the angles are going the wrong direction, the 45 degrees will allow the water to go towards the outlet side of the pad. And what that'll do is there won't be as much time for the air to evaporate the water, and you won't get as much cooling. And what it'll also do is you can get water splashing off of the pad onto your litter. So our basic requirements for the pad system, we want the water to be distributed evenly across the top of the cooling pad. The holes are not, we want to make sure the holes are not in the bottom of the pipe, because what we can get is we can get the sediment collecting in the bottom of the pipe and plugging the holes. We want the 50% of the pad area to be supported at the bottom, and we want to make sure the pad is supported above the water even during the shutdown of the system, so that the pad does not sit in water all the time. And we want to make sure we don't get any algae growing on our cooling pad, like this one here. When we get algae growing on the pad, that will allow minerals into the system, but it'll also start to plug up the holes or take up room for the air to get through the system. Like in this system here, I don't think there's any air that can get through that system. So why should we be concerned about plug pad? If the pads get plugged up, that's going to increase the pressure in the system, which will increase the air velocity, and then that will in turn reduce the cooling efficiency of the pad. And as the pressure goes up here, the airflow of the fan will be reduced. So algae must have three elements to survive. They need light, and they need moisture, and they need nutrients. A pad house can help block out some of the light. So how do we prevent algae? We want to dry the pads out once a day to kill the algae. We want to maybe put the time clock on to shut the pads off at night, say from 10 p.m. till 9 a.m. We want to try to prevent excessive dust and contaminants from getting into the pads. Shade the pads if possible, and the sump. And then if we do have to resort to chemical control to kill the algae, we want to make sure we use a manufacturer's product recommendations, typically a quaternary ammonia product, and we want to follow the manufacturer's dosing recommendations. We want to make sure we don't use any harsh oxidizing chemicals like chlorine, bromine, peroxides, etc. These kind of chemicals will damage the pad and shorten the life. So where do the nutrients come from? They can come from nearby farm fields, roads. Fertilizers can be drawn into the pads. We'd want to make sure we don't allow exhaust air from other processes to blow into the media. And contaminants from adjacent buildings, as well as incinerators and feed silos, they can be absorbed into the recirculating water as well. Munters does provide a list of approved chemicals for algae control, like here, and cleaning and sanitizing. And I believe that may be in the handouts. If not, it can be sent out to you later. We want to dry the pads out. Regular drying of the pads will help slow the growth of microorganisms. Set the automatic timer so that the pads turn off at night. Install a separate timer on the pump to turn the water off at night. And then also minimize the number of drying cycles. Too many on-off drying cycles will weather the pad. Well, here's a simple checklist with preventative measures. Shade the pads and pump and sump. Dry the pads out daily. Avoid nutrient contamination. Drain and disinfect the sump regularly, and use chemical disinfectants carefully. There's no miracle chemical. Make sure you read and the label and understand the ingredients in the chemical you're using. To reduce scale and mineral deposits from the face of the cooling pad, we want to increase the water flow over the pad to help wash any of those minerals off. Make certain the flow of water is evenly from one end of the system to the other end. And then we also want to clean and flush the distribution pipe regularly, especially if you start having dry streaks. And use plenty of bleed off water. So here you can see we want to make sure we flush the header pipe out. And make sure that the holes are pointing upwards, because you can see all the sand that came out of this system. If the holes are pointing down, that would just lead to clogging the pipe up. So chemicals can harm the cooling pads. Chemicals like Clorox or bleach, HDH pool tablets, Agrabrome and Dontabrome, Spa Brome, Aquashock pool treatments, and Oxybrite. All of those chemicals will help to reduce the life of your pad. This pad here was sprayed with chlorine with a backpack sprayer, and you can see that it just ate away at the pad, and we want to prevent that. So bleed off, why do we need to bleed off? Only pure water is evaporated from the system when we run the evaporation, leaving the minerals behind. And so then those minerals will just build up into the reservoir, and we'll get higher and higher amounts of the minerals in the system. So we want to maintain a bleed off of at least 1 gallon per hour per linear foot of your system. And if it's not possible to do that, simply dump the reservoir tank at least once a week. So for an 80-foot system, we would run 80 gallons per hour or 1.33 gallons per minute of bleed off. And then, of course, that can be adjusted as needed. And here's a list of different contaminants that might be in the water that we use on our cooling systems, along with safe amounts, and then the reasons they might be harmful. Like the pH here, we want to run a 6 to 8.5 pH. Low pH is acid and will cause the paper to be brittle, but a high pH is more like lye and can cause the pads to become fluffy, and will not allow enough air through the system. This is what a lack of bleed off can result in. This system had a high pH of 10.7, and this pad, you can see it's very, very plumped up and can't even stand on its own. So that high pH will cause a soft pad. You can just bend it right over on itself. We don't want that. It'll also damage the other parts in your reservoir. Like this here. So with without running the proper bleed off, this system has 2 pumps, one at each end, and one had better bleed off and the other end didn't have any. So the low end had a high pH in the system of 10.3. And that's what the difference between good bleed off and no bleed off can make. These pads are about falling out of that system there. So final checklist, we want to shade the pads and the sump. We want to dry out the pads completely each night. We want to bleed off quantity of water regularly, flush and disinfect the entire water distribution system at least quarterly. We want to avoid harmful contaminants like dust, fumes, harsh cleaners, and water treatment chemicals. And we want to run the recommended quantity of water over the pads. At Munters, we do provide this cooling maintenance placard. It is two-sided, but it's available in a PDF. The office also does have some hard copies that can be sent out, and so it can be displayed in the maintenance shed. Okay, any questions?
We have a few questions that have come in. For those that are left that can actually hear us, I apologize. David, a lot of people can't hear you for some reason. So we're gonna have to rely on the recording to get a lot of these out to people. But one question was, please inform what are the causes of a cooling pad being deformed or worn out regarding stored in a drawer / warehouse at room temperature for future use? And I'm gonna enable Ross to answer as well.
Yeah, so I'm not sure if I'm.
Ross, you're unmuted if you want to help answer.
Yes, I'm not 100% sure. There could be a number of different causes. One is if the pad is not stored flat, but stored on an angle, or and you have moisture in your building, the pad can absorb that moisture. And then if it's blocked one end's higher than the other, you could get a deformation over time.
Okay, thank you. Hopefully that answers your question. The next question that I see here is the method for checking the cooling pad still meets the quality standards, and how often should it be checked? So how should you check, and then how often to ensure quality standards are being met?
There are a number of methods. If you are looking for when do you replace a pad, how do I know if the pad is plugged or not? A typical pad, if you monitor the pressure drop across the pad, you should see about a 0.05, 0.06 pressure across the pad when the pad is new. As the pad ages and you get mineral deposits on the pad, that pressure drop to get air through the pad will continue to increase. And then it's always a question of how soon do I need to replace my pad. We typically would want to see for sure you replace that pad if you have increased up to 1/10 of an inch additional, which means instead of a 0.05, you would be measuring like a 0.15. You would definitely need to be replacing your pad, because what that does is it's going to reduce the amount of airflow that your fans are able to move. Now, in terms of the plug pad, there, as David mentioned in the presentation, there are some cleaners to do, and a lot of that will have to do with water quality is probably the #1 thing that determines how often you need to clean your pad. And the second is the dust and contaminants that are around the farm at the time. But in heavy use, it would be nice to clean the cooling. If you have minerals in your water, it'd be nice to clean it every month. Hopefully that helps answer.
Okay. Let me go back and just check and see if we didn't get any more questions in. And I think we are good to continue. Oh, wait, here we go. One more came in. Is it okay to keep the cooling pads dry without running water for 2 to 3 during off season? I don't know, 2 to 3 what? So basically, is it okay to keep them dry without running water during the off season? I assume they need 2 to 3 weeks or months, some kind of time frame like that.
Yeah, it is okay to pull air through the cooling without water running on it. Now, if you're in the off-season, weather season, you are going to want to protect the pads, put something over the pad to help protect it from the snow and ice and so forth that might build up in the pad. We would recommend some type of a cover. But the best method for helping reduce the algae, as Dave mentioned, is to turn the cooling system off and allow the pads to dry. So yes, we would be good with the air moving through a dry pad.
Okay, and that he responded again, 2 to 3 months was the question. So quite a few,
Yes.
actually. So did you want to add any color to that, Ross, or is that okay? 2 to 3 months, okay?
Yeah, 2 to 3 months is fine.
Okay. Next question is, what is the best solution if the environment outside of the pads is dusty?
Well, if it's
The best
very,
solution is to remove, help to control. Go ahead. Go ahead, Dave.
okay. I was gonna say, one method to help prevent dust getting into the pad was to maybe put up some kind of a screen, a shade screen or something, so that any dust blowing towards the pads will hit that and fall away before the air goes through the pads. Would you agree with that, Ross? Or have other comments?
Yes. Definitely dust mitigation is whether that is applying like like they do on some gravel roads, more of a base for the dust. Some of them I know use like a water base on the road. Some are chlorinated, some are not, to help keep the dust down. The other, yes, a good one, Dave, is what you mentioned, is the netting prior to the cooling.
That answers another question that came in, which was, what advice do you recommend to prevent pads from getting things like feather and debris stuck in them? And I think you answered that question with sort of a screen of sorts, right? That was one of the questions.
Yes.
Okay. We'll take one more here, and then it's, can the cooling pads flute angles be altered to match the cooling demand depending on the ratio of sensible and latent load present? How does that work?
There are manufacturers of pad that have different angles of pad. For our purposes, we use the 4515 pad, as Dave mentioned. Munters does offer different flute angle pads depending on your particular situation. And we would be more than happy to, not here in this, but as a secondary, contact us, and we'd be happy to work with you on the different flute angles and for your style of needs.
Oh, the follow-up question, and then this will be the last one before we move on. We've got enough time here. That's why I'm taking a couple extras, and it sounds like we have a lot of pad questions. So one, what is the distance that a shade screen should be installed before the pad, or between the pad and the shade screen? What's that distance? What should that be? Do you have a recommendation?
Yeah, our recommendation would be that we would want it at least the height of the pad. So if you're using 6 foot high, you're going to want to be preferably 6 foot away. Is a good rule of thumb. Can it be less? Yes. The mesh of the shade cloth will help determine, the square footage of area that maybe you need to put in. If the ends can be open, that's also a helpful method as well. If you make a box, make sure that you allow air in on the top, the sides, as well as the front face.
Okay, I think we can move on to the fan maintenance section now, David. You, Ross.
We'll go ahead and move on here to the fan maintenance. So like the cooling maintenance placards, we also have these fan maintenance placards. Again, it's two-sided, and it's PDF that I believe is in the handouts, but can also be emailed, or we have hard copies available. So for belts and belt tensioners, for our link belt, our red link belt, we can remove a link to tighten the belt up, and then also for the V belt, we tighten them with belt tensioners. There's several types of belt tensioners available. This one here is the one that we use. So as you after you've removed a link to tighten up the belt, and you're putting it back on the fan, when you get the belt into this position, this is where the belt, you would want the belt to be tight before it snaps back on. Here on the right at 7 and 11, this is our current configuration, and then our older fans at 9 and 5. And this is a typical installation of the belt tensioner. Different manufacturers use the same style tensioner, but it would be in different locations. And here's just a typical installation of another one of our belt tensioners on another one of our fans. So along with the belt, we want to make sure that all the alignment or the pulleys are in the correct alignment. We want to check the pulleys for any grooves. We want the nice smooth surfaces. We don't want any rounded surfaces like we see there. So this is the proper placement of the pulley, or of the belt in the pulley. It should ride up just above the edge of the pulley like this, and this would be a very worn belt and pulley. So for normal pulley sizes are about 3.5 and 10.5 inches with a fan of 575 RPM. So if the belt runs a 1/4 inch down in the pulley, then we're going to be at essentially 3 and 10 inches with an RPM of 515. This represents a reduction in fan output of approximately 15%. So that's why it's so important to make sure that the pulleys and the belts are all in good shape. So you want to use a straight edge to make sure that the propeller pulley and the motor pulleys lined up, and also including the tensioner pulley. You want to check the belts. Are they worn or loose? Belts may become thinner as they ride down in the motor and fan pulleys. Replace worn belts. Tightening a stretched belt does not maximize airflow. After you replace a belt, you want to check it after the 3 days of operation, and then you want to do a follow-up checkup at 4 to 6 months. We want to make sure we clean the fans, especially the motors, clean the motors off regularly. That will allow the motor to run cooler and it'll last longer. Also, while you're cleaning it, make sure that the motor is secure. And here, contrary to popular belief, motors do not run on electricity. They run on pre-installed smoke. Electricity keeps the smoke in. If the smoke gets out, the motor's no good. We also want to check the propeller. Is the propeller secure? Is there any damage to the propeller? Check the fasteners to make sure all the fasteners are tight. And with our bearings, we want to grease the bearings every 4 to 6 months, but no more than 2 shots of grease each time. Any more than that, and you're likely to blow the seal out and shorten the life of your bearing. We want to clean the shutters and guards. Dirty shutter of the fan by clean and feathers and dust weekly. Also, clean the guards, because the guards will reduce the airflow as well. And are there any questions about the fan maintenance?
All right, David, I had to find the mute button. We do have a few questions.
Okay.
Give me just 1 second to pull those up. I know one of the questions that came in earlier for us was what kind of grease we would recommend.
Well, I know that's listed on that fan maintenance placard.
Okay.
So without taking a look at that, I know that it is listed there.
Okay, and then for those of you that are left on the webinar, there is a handout section in GoToWebinar, and the fan maintenance placard is listed there. It's one of the files that is attached. Another question, and I can unmute Ross too, actually. Can you give me just a second
Yeah.
so I can participate?
And if some of you don't get the handouts, you can contact us and we can send them to you.
Yeah, there's an email address right on your screen right now, actually, that you can email in. I wash my fans between groups. Any tips or procedures to prevent damaging the fan?
You got this one, Dave? I'm up.
The only thing I was going to say is just make sure you're not using too high of a pressure on a sprayer. I mean, while we want them cleaned off, if you use too high of a pressure, you can get water into the motor or into the bearings, which will not help. Any other thoughts, Ross?
Yeah, I mean, it's always good once you wash it, especially if you use any sanitizer, to make sure you, after things have dried, you give the fan a spin to make sure nothing has gotten kind of seized up. And as the motor is an electrical device, we would prefer no high pressure washing of the motor itself. It is an electrical device. And if you do, make sure you stay back from the motor so we don't have high pressure being pushed in and trying to take out the bearings or seals on the motor itself.
Question was, why should I spend the money for a high dollar belt if I can get one cheaper elsewhere?
That is a very good question. We try very hard to make sure that the OEM equipment that your fan is provided with is of the highest quality. And so that the fan is designed and performance tested with our OEM equipment on it. While a belt is a belt, not all belts are necessarily made equal, and there are tolerances on the sizes of belts. And so one belt versus another can have a difference on the actual RPM that the fan will run. And to go along with that, why should I buy a OEM replacement motor versus a off-the-shelf motor? Again, the same type of principle. Our motors are developed specifically for our fans, have the correct loading and efficiencies. And if you replace with a different motor, normally, like the efficiency itself can be reduced on the motor. So you may not get the same CFM per watt that you were hoping that you were getting.
2 more questions have come in.
Hopefully that answers.
Yeah, how do you measure the alteration or change of air exchange capacity by knowing the alteration of motor speed?
I'm not 100% on the question, but we have performance tests that are done on the fan, and either in our test chamber in our facility or at the best labs at the University of Illinois. And so we are able to know what the fan RPM is supposed to be. Because most of the fans that Dave was talking about today are the belt drive fans. There is a ratio that, between the motor pulley and the drive pulley, but those are determined prior to the fans being shipped.
Just checking again really quick. Okay, I think that might be it for now as far as questions, unless there's anything else you guys wanted to add to the responses we've already given. Okay. All right, so if you guys have any further questions with us, you can get in touch with us via email or go to our website or give us a phone call, and those addresses and phone numbers are on our website and available on the slide in front of you right now. David, can you advance to the next slide, please? And we wanted to invite you to our upcoming sessions as well. We will be doing these every Wednesday at the same time, 11 a.m. Eastern time. Next week, we will be covering layer house ventilation, and hopefully without audio issues next time. We will look into that and make sure we can give some instruction on how to connect the webinar ahead of time. So we hope to see you again next week for layer house ventilation. Thank you, David, for the time. Thank you, Ross, for lending some support.
Thank you.
Yep, and we will talk to everybody soon. Thanks.
Very good, thank you.